Now let's discuss about our maintenance model. And in this presentation, we have two parts. First, we will describe the model developing, model building starting point. And then second part, we will discuss model itself. Anyway, this is schedule completion possible state diagram from previous presentation. And what we are going to do now, we are going to break down this diagram into three segments. First, it is flight. The next segment is maintenance and fault isolation. And third segment is readiness. And we have flight. As we said, we have here cycle. It repeats over and over again. So under flight, we have flight state itself, and we have landing. When aircraft lands, we can have PR, problem report, or NPR, no problem report. If no problem was reported, we are doing just routine maintenance. If problem was reported, as we said, we need to fix the problem, right? And we have a troubleshooting state. The next segment is readiness, and I think it is clear. Readiness has direct impact on takeoff. And then we have takeoff state under readiness, and next is, as we said, again, starts over again, this is flight. And this is starting point of our maintenance model developing. Now let's move to the next slide, and this is simplified factorial maintenance general model. Now what we are going to do, we are going to go through each segment one by one and try to understand, try to describe each item, each states under each segment. Let's start from flight. So as we said, we number one is availability, right? So we have aircraft information. Aircraft is available or aircraft is not available. If aircraft is available, then we need information about MSN, manufacturer serial number. We need information about schedule/actual takeoff date time, schedule/actual landing date time, information about flight. We can have technical event, as we said. We can have flight interruption, information about aircraft utilization, flight hours, flight cycles, etc., etc., etc. Now aircraft lands. By the way, these points are here. This is landing point. This is takeoff. So aircraft lands, and we can have PR, problem report, or NPR, no problem report. P here means PIREP, M means MyRep. Let's start. Let's first describe our problem report logic. If problem was reported, as we said, we need to fix it, and here is troubleshooting state. The troubleshooting state can have minimum three major outcomes. And let me start here from NFF, no fault found. Number one. What NFF means? Well, let's say aircraft lands and the pilot says, "Dear mechanic, we had left engine high vibration in red zone. Vibration was in red zone approximately 50 seconds. Mechanic takes aircraft. Mechanic is doing EGR, engine ground run, doing different tests, checking vibration computer, engine system computers. And mechanic says, couldn't find anything. Then we have no fault found. Or mechanic checks all these computers, vibration computers, engine computers, and there is some message. Let's say engine vibration. sensor number 1. The next step, suppose next step in the troubleshooting procedure is to reset the system. Reset the engine vibration system. Now what we have, let's say mechanic resets the system and it is successful. Now we have reset OK state. Or it fails, mechanic fails, then let's suppose next step is to replace the sensor itself, vibration sensor, engine vibration sensor. And now we have a removal/replacement state. Brings us very interesting operation state, which is using MEL, minimum equipment list. Now what MEL means? Let's say mechanic calls operation, tells dear operation, I need to change the sensor and then vibration sensor, and I need 2 hours. Operation says, we don't have 2 hours. This aircraft should be ready in 45 minutes, in 20 minutes, whatever, in 30 minutes. Mechanic says, okay, let me check if we can fix this problem when we have time, when aircraft is on the ground more than 2 hours or not less than 2 hours. And checks the MEL. Depends on the category, can be 3 days, whatever, 10 days, right? Suppose this sensor is 10 days, so it means that category has 10 days. It means that we can change this sensor, the failed sensor, failed LRU within 10 days. So when we have time. And brings us to the go condition or go state. So we can fly 10 days with this failed sensor, with this failed LRU. If item is not MELable, then we have no go condition, no go state. Then if it is no go, definitely aircraft is on the ground, AOG, and we have a technical out of service. Now operation can say, hey, do you know what, dear mechanic, you can take your time, we have substitute aircraft, we can spare aircraft. Brings us another to the next operational segment, which is readiness. Again, I'm gonna give you a very simple example. In real life, it's more complex. Let's start from no delay, no cancellation, and I'm gonna bring here our the diagram again from previous presentation. Take this NFF state, right? And let's say mechanic spent 20 minutes. I think it is clear 20 minutes is less than 1 hour, 60 minutes. And in this case, we have no technical delay, no technical cancellation. Or let's say mechanic needs, again, we need to fix the problem, right? 2 hours, somewhere here, right? Again, this is clear, right? 120 minutes is more than 45 minutes or 60 minutes. And what we have, especially if item is not MELable and no substitute aircraft available, we have a delay. Suppose we have more complex problem. We need to replace, we need to remove the engine. Depends on the type, aircraft type, engine type. Can take 7, 8, 9, 10 hours. Brings us to the aircraft AOG, technical out of service. Brings us to the cancellation. So we're gonna cancel this flight. Chance is very low that sometimes, again, depends on the model, right? Operation model, maintenance model. The operation can say, hey, let's take this 7 hour, 8 hour delay, say 8 hours delay, right? There is a chance, but it's very low. Anyway, when aircraft is ready, so we have takeoff state, and definitely we are moving then flight state. Now let's go back to our NPR logic. If no problem was reported, we are doing just routine maintenance. Mechanic is doing routine maintenance. If we have finding during routine maintenance, then it is MyRep. Definitely we have to follow PR logic. If no findings, then we have, probably I needed to put this way here, we have readiness state, right? And then we have again flight. Now this model, as I put here, it is very simple, very generic, very general, but this model is enough to use to visualize our reliability report development. Okay, now let's move to the next slide and try to categorize our operation/maintenance data, again, that we are going to use to develop our reliability report, reliability program. We need to know what we need to collect from this model, from our operation, from our maintenance.